Thank you very much. Thanks for the invitation to come back and present the work from the 2018-2023 research that we did. I think I'm going to talk about sustainable management of leafhoppers on grapes, which was project or activity 17. And I've got Andrea Bronner in there because I retired partway towards the end of it, and we've carried on, and I'll explain for a few reasons for that. But first, team members, a lot of people were involved in this project from various parts of, in the nematode, the anagrus part, the parasite part across Canada. We did a lot of the work here. We had input from people in UC Riverside, University of California, Riverside. What I don't have here because of time restrictions and space, so many capable technicians and students we go through. Every year we have a large number, so I thank them. What I wanted to point out, disruptions including COVID, Okanagan heat dome, staffing changes, etc., caused us to make some changes. But all in all, the research was largely completed as planned, actually with some additions. So we added some things in that I'll present as we go along. So first of all, the first objective was to look at anagrus parasitoids in BC and Ontario, and these little tiny dots, if you can see them, I don't know if, see these little specks here, these are enlarged quite a bit. That's your little tiny mimerid egg parasite of leafhoppers. And it's one of the most important natural enemy control agents for leafhoppers on grapes in British Columbia. So anagrus were collected from leafhopper eggs on grapes as well as from alternate wintering hosts. So the parasite moves out of the vineyard for the winter, finds another host, and comes back into the vineyard the next year. So we're interested, of course, in the alternate hosts in particular, because where are they going? We know that here in BC, we start off with relatively low numbers each year. So if we could build up numbers of the alternate hosts, we might be able to give them a head start, so we'd have a lot more. In the next thing is identifying these little things. So as you can imagine, we worked with Dr. Sergei Triapitsyn. He's a taxonomist. But these little tiny specks are so hard to do that our taxonomists in Ottawa don't even want to handle them. They don't want to look at those. So I can't see how molecular work is much easier, but that's what we had to do. So Dr. Grape and the London Ag Canada Research Station, she's done a lot of work on that, as well as more recently a lab in California that I'll point out later. So molecular and taxonomic identifications were very important. In here, we wanted to determine if parasitism of leafhopper eggs by these little tiny anagrus wasps is responsible for the very low numbers of Virginia creeper leafhopper that we've seen at several Okanagan locations. And we'll come back to that. So that's kind of the overall objective. So partial outcomes from objective 1. Good news for people in the Fraser Valley and on the island. There are no leafhopper pests on grapes in those regions. We couldn't say that it was due to high rates of parasitism. That was one of the theories, because we just didn't find leafhoppers. So presumably they may have played a big role. We did get a lot of information on alternate summer and winter hosts in Ontario and in the Fraser Valley. There's another species of anagrus called Anagrus chardiacove that tackles both the Western grape leafhopper and the Virginia creeper leafhopper that we have. We were hoping to find that because it overwinters apparently on roses. We have lots of roses. That's why we have lots of high rate of parasitism of the Western grape leafhopper, but we couldn't find it. So it's not here yet. It does lead to the possibility, though, that maybe we can have that brought in. We can have it imported into BC. We did a thorough search. We did find a brand new species of Anagris called Anagris oceanicus from dormant willow. And we're just preparing a paper on that now. So we really, thousands and thousands of anagris and leafhoppers were collected. We've got a partial set of molecular markers for the anagris and a link with the diagnostic lab of Dr. Rugman Jones at UC Riverside, who does molecular work as well. Dr. Kitts, he's a leafhopper specialist. He does that group and others in Ottawa. He's got molecular sequence data for 120 leafhopper species for taxonomic reference. So we're now set up, you can actually take parasitized eggs and run the markers, run them through the molecular testing. You could tell what leafhopper and what anagris parasitoid's gone after. So that's a real step forward. More partial outcomes. So we found the unexpected declines in Virginia creeper leafhopper numbers at 2 sites is associated with high rates of parasitism and with trees in the prunus plant family, cherry, apple, etc. Both places, and this picture down here is important because it's close to where I live, which includes one of the sites. That used to be just brown by midsummer. This was late fall, and you can see it's still green and lush. And that whole area, high rate of parasitism, hardly any leafhoppers in the area. So lack of leafhoppers at another site explained by sprays of an organic fungicide, and I'll come back to that in a minute. Objective 2, evaluation of oils and insecticides. We need new products and procedures for leafhopper control. For organic, for example, we only have, well, you could use pure spray oils. I think we're working on getting that registered. So we did evaluations of oils and insecticides in the field, the greenhouse, and in lab bioassay that I'll show you in a second. So leafhopper oil spray field trials. Hans Buchler kindly helped us with this. We had one of his sites, he used his fancy sprayer. So you can see in 2021, 2022, and we had quite good control when you use the proper, really good sprayer. An air assist sprayer we could get with Veg-All 2%. We could get, this is a single spray, and they recommend that you do at least 2 sprays. So 81% decline or level of control with this air assist sprayer. But even with one of these vertical type sprayers, 71% is pretty good. In every case, the Veg-All did better than the pure spray. I think there's some work that can be done to figure that out. Veg-All has a lot of surfactants in it. It's really foams up and gets quite fuzzy. So you'll see in a minute why that could be an important part of this. I put this one in just to remind me to tell you that we always try to get information out to growers. So the work on the oils gave a couple of talks, talk in Ontario, talk here, and put out a newsletter talking about how proper use of oils. So the next one was modeling leafhopper development. So the objective is to improve timing of foliar sprays against early instar nymphs. So typical situation, you record the temperature, grape phenology, and you assess leafhopper population development. It has to piggyback on grape development because they don't have the same thresholds for development, and the leafhoppers can't start laying eggs and developing until the cuticle on the leaf is waxy enough. The leaves have to be mature enough. So it's going to depend a bit on the variety and the spring conditions when it kicks off the whole system. So Possible value, also recording flowering of common indicator plant species. There are some models that use that. I developed one in Ontario they still use for root maggots on crucifer crops. You simply, for first generation timing of sprays, you watch for the common lilac to be out full bloom, and that's the timing for spray. So here's our temperature. We had several temperature recording devices. And then what we're trying to do is monitor at various times, hatch of the eggs, and then following right through with development stages. So here's the model that we had for 1 year that I'll show you. You probably can't read everything back there. It's not too bad. So here's for leafhoppers. And there's 2 curves here. The growing degree days. This is base 10. This is base 8. And we have various action thresholds that you would implement at various times. And what you can look at, we had a really quite a nice curve. Everything worked out pretty well. For example, peak cottony vine scale, we're working on that as well. So there's timing of when the crawlers occur. So we can use these, we hope, these temperature models that we can use to predict exactly when, for example, you would want to do, this is 79.25% leafhopper egg hatch. So that's when you put on your first oil spray. Your second oil spray would go here. And this is, this is a very useful tool to implement all these changes. Those of you who have been looking at this and are observant of your situation in your field will notice this is first generation leafhoppers. It started to go back up for the second generation, and then this question mark, it never developed. How much time do we have? 3.5 minutes. Okay, I'll go a bit faster. And I'm going to come back to what happened here. I'm going to explain this to you. So we do lab efficacy trials, feeding choice tests, and we do pesticide efficacy. And we're using excised leaf discs that we treat, and we put them in on these grids with these wire grids. And for treat it, put the nymphs on it, and then record either mortality or where they end up, the position. For efficacy trials, we have some results from some of the work we've done. If you look at Pyganic, the ones in dark red were very effective. You look at this, this is simply a measure of how strong the effect was based on it's a chi-square value saying there's a strong effect. Pyganic is the standard registered organic material that people use. For comparison, Bexar, a new one we don't have registered that I hope they pursue, it was also a very good material. So this works quite well. We took Bexar to the field, and thanks to Dave Neal and others for helping with this. And the nice thing was our results from the lab mimicked the results from the field, very good levels. So Bexar was very effective for leafhopper control in the field. And the nymphs the counts we had were mostly newly emerged nymphs that would have been in the egg stage when we applied the spray. So they would have emerged afterwards. So it was very effective, and a nice thing, it's effective against both the Virginia creeper leafhopper and the Western grape leafhopper. The Western grape leafhopper is more resistant to pesticides, or less susceptible. So if we control that, that's great. Choice tests, we did a lot of work on choice tests or anti-feeding, and this is over a number of years, even predating this last one, but this is looking at, again, treating the materials and looking at movement of leafhoppers off the leaves. And if you look at these, a number of surfactants, these strobel urine fungicides are here. That's these ones that are strongly active. And organosilicon surfactants, all of these dark red ones that are highly active. Going back to that graph I showed you, we didn't know it. We did not request it. 2 materials had been applied that caused the decline. They were this fungicide, which we've since then done some work. Sirocco, the active is potassium bicarbonate. We've worked with Millstop. It is also a very strong anti-feeding to leafhoppers. When we worked with the pure potassium bicarbonate, there was no effect at all. So it's not the potassium bicarbonate, it's the surfactants. And we get back to this, what I've shown here. It's these organosilicone surfactants that are very effective anti-feedants. So with that, we did a lot more. I didn't have enough time to go into everything, but we've increased our knowledge on the biology and relationships of anagris parasitoids with their leafhopper hosts, found out a number of overwintering hosts. Molecular markers have been developed for anagris and their leafhopper hosts. We've initiated, and that's being carried on, temperature-based developmental models for leafhoppers and scale insects. We've assessed activity of summer oils with respect to sprayer technology, identified insecticides that are very effective for control of leafhoppers on grapes, and that'll have to be carried forward, consultation with the companies to try to get some of these registered. We've identified some materials that are strongly anti-feeding to leafhoppers. I showed you that picture of the model. It verification of what we were finding before. So we provided along the way a lot of information to growers through talks and newsletter articles, annual progress reports, updated the insect and mite section of the BC Grower Guide, and we're still working on manuscripts. We have 2 of them that will be going out in a month or so. So acknowledgements, of course, we thank Agriculture and Agri-Food Canada, CGCN, BC Wine Grape Council, and there's a lot of people involved. The wineries, we did a lot of work on site with industry members, and we had a lot of help from field services here, a lot of technicians, and of course, we have to thank all the various students who jump in during the summer and do tons and tons of counting. Thank you very much.